I have a confession to make. I am not good at knife throwing. I just can't get them to stick into the target. So I figured it'd be easy to build a machine to throw the knives for me because I'm just so darn good at building robots. But making a knife throwing doohickey is not as simple as giving a knife to Mr. Roboto and letting it go buck wild. That would be irresponsible of me, and it wouldn't let go of the blade, which kind of defeats the whole purpose. In fact, making a robot that throws knives isn't shrimple at all, and this past month has made me seriously question what length of school bus I should be riding in.
I hate you.
Now before I show you how I got to this point, allow me to go over the goals for the robot real quick. Okay, my first goal is to survive making this video. My second goal is for the robot to throw lots of knives, as seen here in my best paint work to date. It should also have an onboard live feed camera and be able to remotely control my sphincter. But before I could design anything, I had to start with this. The dullest knife in the world. Now there are many different ways to throw a knife, such as a half spin, a full spin into a half spin.
No way.
But let's be honest here, there is a 0% chance I am smart enough to figure out how to make a robot rotate a knife in flight for it to land point first into a target. So instead I'll be using a technique called flat throwing, where you begin with a pelvic thrust, stopping on your right foot and making sure not to forget it. Then you have to bring the knife around town, and if you let go at the right time, you will be astounded that that actually worked. To see if this technique would even work on a robot that's incapable of thrusting its pelvis, I ooga-booga'd a piece of wood to my drill and hung a knife off one end, but the whole thing was a little unbalanced, which made it kinda sketchy, so I simply balanced it with another knife. This surprisingly worked quite well. We'll work on a better knife release later, but for now I want to replace the drill motor with a motor, sans the drill, that I can control electricitally with an intelligent conglomerate of sand to spin up the throwing arm. Thus far I've been using dweens as robot brains for all of my projects on this channel, but today I'm stepping into the 21st century and learning how to use an ESP32. Now imagine the ESP32 as a cracked out Arduino Uno on Ozempic and you'll have a pretty good idea of its capabilities. It can yap with Wi-Fi and has blue teeth from the factory and can even turn on an LED.
Oh, let's go!
But the real reason I'm using this little firecracker is for the Camgirl version, which allows me to host a web server and live stream a camera feed which I can access on a browser. Now I can charge $10 a month for live stream access to pay for my BBL. All of that's pretty insane for something the size of my pinky if my pinky was slightly bigger. The next step was to interface the 30 deuce with my motor, but I can't directly connect the two together because the wires are too short. Instead, I'll have to use this motor driver that's chambered in a standard NATO round as the middleman between the two. I then struggled to get the motor to spin for an hour until I changed a 1 to a 2, and now it works perfectly. Boy, do I love coding. After carefully transporting the electronics to a bigger table and 3D printing some test knives because the metal ones could accidentally poke something important, I had the motor work the shaft in such a way that excited the wood up to a couple Benji's worth of RPMs.
Okay.
Nothing broke until the instant I stopped filming when the shaft coupling lost its load. But that's okay, because this wood piece is an abomination and I need to replace it with something more robotic looking, such as this beautifully maintained piece of aluminum. Now believe it or not, I choose not to, I don't have a mill, so I can't machine an aluminum part. And after calling around at the local job shops to get my robot arm made, it wasn't looking good.
$700? What do you think I'm made out of gold? No, Midas touched me is just my email address.
That is until I was paid to randomly stumble upon this website called JLC CNC, which specializes in quickly making custom CNC parts for cheap and just so happens to be today's sponsor. This is what JLC CNC looks like through a monocular, and to show you how easy it is to order your own custom CNC parts from them, I'll be attempting to order my robot arm across the room and upside down before I pass out.
Where is the mouse?
JLC CNC is your trusted CNC machining partner, whether you like it or not.
Oh yeah.
They offer quick, affordable, high-precision custom parts for engineers, psychos in their garages, businesses, your grandmother, you name it. Anyone can get in on the action.
Oh, great.
Whether you have commitment issues and just want a single prototype, or if you're looking for a long-term relationship filled with thousands of passionate part makings, JLC CNC loves you and will treat you right with competitive prices and no hidden setup fees.
Tolerance? Medium's good with me. Don't matter. It ain't that deep. How much is that? 60 bucks? 40 bucks? Already got my quote? Heck yeah, it's that easy.
And once you order your part, JLC CNC can deliver it to your front door in as fast as 3 business days, which is just insane. Don't miss out on JLC CNC's special offer of $70 worth of coupons, which could make your custom CNC parts cost as little as $1. And once my beautiful aluminum arm arrived a mere 6 days after I ordered it, I immediately learned that aluminum loses to rock, which makes you appreciate the raw power of paper that much more. But aluminum does beat wood in this case, just not my wood. Wait a minute. Were you not going to explain whatever that is? Remember how this robot is supposed to throw knives? Well, to do that it needs a controlled way to release them, so I made this thingamabob that holds 6 knives and can release one at a time by pulling a bob-a-thing back a secretive amount each time. I turned this into a pack and Rinyan system, but needed something to mount it to, so I made this disgustingly ugly print that only your mother could love, and after stealing a servo to drive the gear, mating everything together, and loading the knives, I made sure to get a good angle to see if it would work.
Is it working?
I did a good job of hiding it here, but I was actually pretty excited that it worked. And now that we're all caught up, I began the arm installation process by carefully mounting the arm coupler to the shaft and then attempted to mount my finger to the coupler. I then coupled the arm to the coupler of arms and then put the whole thing on the motor. Next, I installed the knife holder assembly onto the throwing arm even after I dropped my nut and you refused to help me look for it, which I did not appreciate.
Where'd it go? Can you see it? Point it out for me.
Finally, everything was ready for a spin test to see if the motor could even move all of this proverbial junk in the trunk. It was kind of janky, and it looked like some biblically accurate plane propeller, so I cranked up the speed to see if it would smooth out and hopefully hold together.
Okay.
Everything was working suspiciously well, and now I wanted to start throwing knives, but those who don't have this playing on their second monitor may have noticed the servos are connected to air, which isn't a great conductor unless the electricity gets angry enough. Luckily, these servos are mild-mannered, but if I connect directly to the microcontroller, the wires will just get tangled and snap. Don't believe me? Check this out. Believe me now? And I could have sworn there was an invention that could be stationary on one side but rotate and pass signals through on the other, but I can't remember what it's called. Well, I couldn't remember, so instead I bought this slip ring that's pretty fun to play with, but the inside better be made of actual gold because I paid $62 Ruskies for this glorified fidget toy. But how does a slip ring even work? To help answer that, I've got 2 pieces of wire and a bearing. If you loop the first wire through the bearing and connect it to itself, and then take the second wire and throw it away, you'll understand I have no idea how these things work. And once I connected it to the arm and neutered the robot by removing the scary metal knives and replacing them with their plastic counterparts, I was certain that some knives were about to be thrown.
Okay, now release. Yes! Yes! It worked!
Hold on to that happiness, bud, because where you're headed, it's in short supply. Right now, the knives release when the urge to do so calls, but the next challenge is to get them to release at a specific point so I can actually hit targets. To do this, the robot requires omniscience of the speed of the arm, the position of the motor, and servo actuation time. The speed of the arm is pretty simple to find, and I'll just measure the rotations per second and inform the robot so it can adjust accordingly. These motors are actually stepper motors which know its position by counting the steps, and if you listen closely you can hear each step as it rotates. Step. And by tickling these motor driver switches just the right way, I set up the motor to do about 350 steps per revolution, which is a lot harder than you may think. Finally, we arrive at servo actuation time, and then immediately depart because at this point I just guessed. With the 3 key ingredients now stewing in the robot brain, I cheated a little bit and physically pointed out where the knife should go, which probably made it easier for the robot to do this. Now, as cool as that looked, it was pure luck. I ran the exact same test again in Slow, and this time the robot power slammed the knives into the concrete. I decided to blame arm slippage for this war crime against the knife people, so I began to make a better test setup by installing everything on this conveniently branded box. It looked a lot cooler now, but the arm was going to hit the non-turning table, so I mounted a yes turning table to the bottom and then put it all on a little test stand. And since it already swivels, I might as well install a motor into the test stand and then put them together. But that still wasn't tall enough to clear the table, so I handcrafted another box and stacked it up. It was kind of wobbly though, so I printed these L brackets, installed them, and realized I accidentally made the whole robot. My bad, playa. The final piece to this awful puzzle was this awesome hat, but these holes ain't here just for looks, they're for looking. The round hole is for the ESP32 camera to gander through, while the round hole is for the visible laser I bought because lasers are cool and robot-like and I just blinded you. My bad, pimp. But just what's gonna go in these round holes? The world's smallest pair of binoculars? Don't be ridiculous, you know I need you. To understand it's just a LiDAR sensor. I then partook in 6 hours of what a snake technician must feel like, but once they were all caged, they behaved correctly. And after checking that the LiDAR sensor was detecting the right range, it was finally time to take the robot for a spin. Now I just needed to throw the knives at the target. That should be really easy, right? Welcome to the next 87 hours of my life. I don't have any snow cones, sorry. At first it was just being a greedy little freak and wouldn't let go of the knives. Then I whispered sweet nothings into its processor and it let go of a single one in the wrong direction. Next it got angry, threw some knives, and just stopped spinning. This thing has one nasty attitude, but I was determined to beat my fingies into the keyboard for as long as it took to get this thing working. I tried and even tried again, but for the life of me, it would not throw the knives where they should go, and I was starting to lose my cool.
It's going the wrong way. I hate you. Why is it rotating the wrong way all of a sudden? I haven't changed anything. Well, can I dream?
And that's when I finally realized maybe the plastic knives are the issue. So I constructed a little box for the bot, loaded up the metal knives, and hid away in a corner.
3, 2, 1.
Now that was promising, but I'm pretty sure the knife tip isn't supposed to look like that. So after beating the tip back into place, I loaded the bot back up and hopefully could stick a knife this time. But from there on out, it looked like a 1.0 GPA student's report card. It was fail after fail after fail, a small lecture.
Look, this is how you do it. See, boom. That's all you need to do. That is literally all you need to do.
Addressing down, and then right back to failing again. I tried everything until finally... Now it may not look very impressive, but I have been cowering behind this stupid piece of plexiglass for so long that I would have been happy if the knife stuck in me instead. I did get the knives to stick a few more times, and even got this cool double stick. But the robot was super unreliable, and I tried everything to fix it. I measured the servo actuation time, reviewed slow-mo footage of the knife release in flight path. I printed these spacers because the knives were coming out wobbly. I made sure the arm wasn't slipping, but there was something inherently wrong with the robot because even if I changed nothing at all, the outcome was drastically different. Besides, the webcam wasn't even working, and I knew that I was going to have to rebuild this thing from the ground up to make a proper knife-throwing robot. But for old time's sake, I booted the robot up for one last test, and then it happened. This war crime against the knife people. The knife people, the war crime. I decided to blame the arm slippage for the war crime against the knife people. Oh, hey ho.
This is why I don't trust this AI garbage. Look at this. Knife speeds 14 to 50. Professional baseball can reach about 40 miles per hour. Hold on, that seems a little slow. Well, let me look up the baseball speed of a fast throw. Oh, 95 miles per hour. Yeah, great job, Google. You